So let's look at this grammar. So using this, you can declare a single variable with a type. Okay? So let's look at this grammar. Here, this B represents the basic type and the C represents the composite type. Okay? So এবার ঠিক আছে? এখন আসতেছে? আচ্ছা, anyway, so this B basically stands for the basic type and the C stands for composite type. Okay, so we are dealing with two basic type. One is an integer and another one is a float. There are other basic types like double, okay, then character, okay. So we are dealing with a basic type and a composite type, and this composite type can be other composites type, but we are dealing with an array here. So this C will represent multi-dimensional array uh, that will be numbers enclosed by the third bracket. Okay, so numbers enclosed by third bracket. For example, 3. If it is a two-dimensional array, 3, 2. Okay, and if it is a three-dimensional array, it will have more. So 3, 2, 4. Okay, so this T is for type, and this B is for basic type, and this C is for composite type. And the basic type we are dealing with is basically integer and float, and the composite type we are dealing with is a array. Okay, there are other composite types like records, structures, list, linked list, right? But we're only gonna deal with an array here. So it is saying that T can produce a basic type as well as a composite type. If it is a basic type, it will be an integer or a float, and if it is a composite type, it will be an array, right? So if we are initializing multi-dimensional array, for example, how many dimensional array is this? Everyone, can you hear me? Hello? Okay. আচ্ছা, একটু প্রবলেম ছিল, আমি আপনাদের কথা শুনতে পাচ্ছি না। So how many dimensional array is this? Two dimensional array, right? But do you know what is the type of this array? This is a two dimensional array, that is fine. But what is the type of the elements? Can you know from this syntax what is the type of the elements? So we need a basic type, right? So the type can be either integer or float. This means this is a two-dimensional array of each element being an integer type. Okay, so this array has two rows of three elements. So basically this array is like this. It will have three elements in each row. Suppose one, two, three. This is the first row, and two, three, five. This can be the second row. Okay, so this is a multi-dimensional array. Okay, so with this grammar rule, we can produce other multi-dimensional arrays. Okay, so this C can produce a one-dimensional, and again the C itself, and the C can finally be epsilon. So if you want to produce just one-dimensional array, so you can write C produces number C1. This number will be 3, and this C1 will be epsilon, right? So this C and this C1 is basically the same non-terminal. It is meaning this non-terminal is in the production head, and this non-terminal, it is the same non-terminal as this non-terminal, but it is in the production body. That's why we have added the uh, um, suffix 1. Okay, and if you want to make it multi-dimensional array, all you gotta do is this C, this number will be 3, and this C will again produce, this will again produce number C1. Okay, so from here we can have 2, and this can go to epsilon. So we have this array 3, 2. Okay, and from this B it can be either integer or float. Okay, so is everyone clear on this part? Okay, now let's look at the semantic rules here. So what are the semantic rules say? So whenever we draw something, we draw a tree, suppose. Okay, so this is your syntax tree. And if you do depth first search, it becomes integer square bracket 2, 3, and epsilon. So it becomes this syntax. Okay. Now, so what is this semantic rule saying? So this semantic rule is saying, because we have two types, this attribute T is of synthesized type. Okay, the attribute T is synthesized type, and the attribute B is of inherited type. Okay, so it has two attributes. This semantic rules has two types of attribute. It has both synthesized attribute and it has both inherited attribute. So the non-terminal, that T and B and C, both of them have the attribute T, right? This T attribute is basically your synthesized attribute, but the attribute of C, which is dot B, is a inherited attribute because it is taking the value from B dot type. So it is taking the value from this place. Okay, so we have T dot type, and we have C dot type, and we have C dot B, and here we have B dot type. We have B dot type. Again, we have C dot type, and we have C dot base type. Okay, and here again C dot type, C dot base type. Okay. So how these values are being calculated? If you see here, the if you look at this example, the type of uh, B, so B is producing integer. So the type of B, if B produces integer, B dot type is integer. So this is int. I'm not writing the full word, so this is integer. Okay. Then we move to this part. Okay, so this is the production, T produces B, C. So this is the production, T produces B and C. So the C dot B is getting value from this integer, which is integer, and T dot type is C dot type. So T dot type is basically C dot type, but we have not calculated C dot type yet. Okay, so C dot B is basically going to be same as this one, which is integer. And you need to write the full form of integer like this. Okay, now yes, arrow দিব, বাট এখানে arrow দিলে বেশি clutter হয়ে যাবে. Okay, so let's first write the annotated parse tree. In annotated parse tree, you do not need to give the arrow. You only need to give the arrow in the dependency graph. Okay, so I'm first drawing the annotated parse tree. But we do not have this value C dot type. We do not have the value, and that value will be passed to T dot type. Okay, now let's see. So this integer value is going to get propagated to downwards. How? If you look here, if you look at this place, so C dot type is equal to C dot B. What is the C dot B? C dot B is this one, right? So we are going to propagate this into a synthesized attribute. So this will go from here to here. So this C of B will be passed down from here, and it will be passed down from here. So we get integer, right? So this type will be passed to this one. See, C, using this rule, we are passing down the type which is integer from this C to this C to this C, because all of them follows this production rule. Okay. So what does this production rule say? C dot type is equal to array num dot value and C1 dot type. So this, we using this rule, this will get propagated. C dot B will get propagated to here. C dot type. Okay. So from here we'll get the value integer here, and from here we'll get the value integer here, and from this value it will propagate to here because of this rule. Okay. So the C dot uh, this one is integer. Okay. Now when we're calculating the value of this t, we're using this rule because C produces epsilon. Now we are going to look at this rule. We're going to calculate the value of t. What is the value of t? It is array. I'm writing just A for array. I'm not writing the full thing. You need to write the full thing. Array of num dot value. What is the num dot value? It is 3. Array of 3, and the type of C1 dot t. What is the type of C1 dot t? It is an integer. Right. I Again, we're going to use this rule to write it here. What is the value? The value is array. I'm not writing the full thing. What is the num dot value? Num dot value is 2. So array of 2 comma, what is the type of C? The type of C is basically this whole thing. It is again another array of 3 elements of type integer. Okay. And this type will be passed to here. So we can basically say the type of the whole expression is basically a two-dimensional array with two rows and three columns of each of the element being an integer. Okay. So the whole type then becomes this thing. The whole type then becomes an array of two, meaning this is an array, this is an array, and it has two elements. Both of the elements are again another array. Okay. So it is an array of two elements, and those two element itself is an array. Okay. Those two elements itself is an array. What type of array is that? Those two elements are the array of three elements, each of them being an integer. So with using this expression, we can say it is basically a two-dimensional array of integers. Well, the row value is 2 and the column value is 3. Okay. Any questions regarding this, and how the values are being propagated? Okay. So you can see we're getting the value of integer from b of t to this c of b, and we're passing down the value from this c of b to this c of b. Okay. To this c of b, and after that from this c of b we're getting the value to c of t, and then we are propagating the value upwards. Okay. So we are getting array of three integers and array of two arrays of the three integer array. Okay. So this is basically how this grammar works. Okay. And these are the semantic rules. Any questions regarding this? Any confusions? Okay, so far we are reading about type expressions. Okay, now let's define what is a type expression is. It will be far better to understand we know the definition of type expression. Okay. Even though this is not the part of your syllabus, but you need to know what is type expression. Okay. So types, basically we are dealing with types, right? What is the data type, what is the name type, right? We are dealing with types. So types have a structure which can be represented using type expression. So whatever we have seen, this is basically a type expression for this integer of two-dimensional array, and each of the dimension will have three-dimensional array, right? So this is basically a type expression of this part. Okay, you can have methods, you can have functions, you can have linked list, right? Those will have separate type expression for themselves. Okay, so type expressions can be defined into few parts, like this part is basically a type expression which is a basic type. This is a basic type expression. So integer, float, void, right? Character, boolean, these are the basic type expressions. And they can have composite type expressions, which is an array, right? uh, Array, or any type of uh, methods or linked list, right? So these are the composite type expression. So type expression can contain both a basic type or a composite type, right? Or a name is also a type expression. Why do we use the name, right? So suppose for classes or structures we use the name, right? So these are also a type expression. Okay, and there are other types of type expression as well, like for functions and all, which will be not covered in the syllabus, but if you want you can look it up. It is in section 6.5. So these are basically the type expressions. So type expressions are a way to signify a, a code, right? So this is basically introducing the type expression for this syntax, which is basically a two-dimensional array. And with the help of type expressions, the computers or the compilers can easily allocate a certain amount of memory in your system for that data, right? So suppose we have two-dimensional array, right? And so we have two-dimensional array, two rows and three columns of integers. Can anyone tell me how many size would be needed? Suppose this is a 32-bit system. So in a 32-bit system, we need 4 bytes for an integer value, right? So how many size would the system need to accommodate for this array? Can anyone tell me? So let's count. So each integer contains the, so from this type expression, the compiler can easily calculate how. For each integer we need around 4 bytes. So we have three such integers like this. So this array will contain how many? 3 into 4, 12 bytes, right? And we have two of such arrays. So total will need 24 bytes for this array. So the compiler, after receiving this expression, it will convert it into a type expression, and this, with the help of this type expression, the compiler will allocate 24 bytes of data in the memory for this array or in the symbol table. Okay, is it clear? Because that's how the architecture works. If your architecture takes 8 bytes, so you will calculate for 8s, but in most of the computers, in uh, 32-bit system, we or 64-bit system, we typically use uh, 4 bytes to store an integer value. Okay, so 4 bytes is basically 2 to the power 4, this many spaces. Okay, so this many spaces are used to hold a integer value. So this many spaces will be occupied by zeros and ones, and this can have this many combinations, right? So with the help of this, you can easily calculate what will be the lower type of the lower value of the integer and the higher value of the integer. And if you want to allocate more bytes, so the upper limit for your integer will be much bigger, and the lower limit for your integer will be much bigger, meaning your system can hold bigger integer numbers if you allocate more spaces for your uh, variables. Okay, is it clear? Okay, so this is basically the type expression. You can read about type equivalence as well. And okay, so now we need to deal with this declarations, right? So we have type expression grammar, which we have covered, and we have also seen the attributes of an array type. Okay, now we need to see about the sequence of variable declarations. So this is a grammar by using which you can declare multiple variables. You have already seen this part. Okay, this is the grammar. We do not have any semantic rules associated with it. So we have already seen this grammar, right? We have already seen this grammar. Any questions regarding this? So this grammar is basically this grammar, right? We have already seen it. So we are adding few more things. What are those things? That this type can be an array type. Okay, it can be a basic type or it can be an array type. Okay, so this part basically contains a basic type and an array type, or it can be of record type. Okay, what is record? Records are basically like this. Record, you'll have some variables. So these are basically like classes. So you need to name this record as well. So suppose the record name is uh, some value. So the record name is some value. So we use the record keyword. We use this curly braces, and within the curly braces we have many attributes. So what are these attributes? These are basically known as the fields. So if you think of it as a class, every class has some variables, right? So these are the variables, or you can think of it like a structure, the structures that are used in C language. Okay, so this is same, this will only have variable types. Okay, so what we are saying, in the records we have the record keyword and the opening curly braces and the closing curly braces, and between the open and closing curly braces we have d, right? So what is basically d? D is a uh, declaration, a declaration of a variable. This variable can either be a basic type. If you look at here, so what is this d? D is basically a declaration variable. It can have a single declaration variable, which is t is tid, right? So d can produce tid semicolon d or epsilon. So what it means, d can produce tid semicolon d epsilon, right? So this T can produce B or BC or record, right? This can be either integer. This T can be integer, right? Suppose this C is epsilon. So T can, so this T can produce B, C, and this id will be a attribute name. So any identifier in your symbol table, it can be first name, it can be last name, or it can be value, right? Or it can be uh, any variable name. So suppose the variable name for this is a, okay, and the terminal semicolon, and this d can produce this value again, this value again, or a a d again, right? Sorry, I have made a mistake. So here we are only going to initialize the variable but not declare it. So this grammar doesn't let you declare the variable. So this grammar only lets you initialize the variable and not declare it at the same place. Okay. So suppose this d is going to be epsilon. So this is epsilon. Okay. Now suppose this b is integer, and this c is epsilon, and this is a basically. So from this we are getting int a, which is a variable declaration, right? Okay. Now suppose this d is not epsilon. This d will produce again. Okay, so this d will produce this value, d id semicolon d. So instead of producing epsilon, it will produce this value. Okay. So let's again, this t can produce b or c, and this can produce another variable name, suppose b. This will produce semicolon, and this time this d produces epsilon. Okay. Now, so here a b will be float, c will be some value producing this one. Okay. So it will produce number, number bracket, and it will produce another c, and this c will produce epsilon. This b will produce, so this is basically your identifier. This b will remain the same, and this will remain the same. Now we have multiple variables declared in a single line, which is int a and float number. Suppose the number produces 3, right? So float of 3, which is b. So we have two variables, which is a, and the type of a is integer, and we have another variable, which is b, and the type of b is the array of floats containing 3 elements, right? So you can see, using using this grammar we can easily declare multiple variables in a single line. So that is why it said record D, right? So the record can, inside the record you can have multiple variables declared like this. Inside the record you can have multiple variables declared. Okay, so this tip can, instead of producing this integer value or the float array value, it can also produce a record value, right? So suppose this could be integer a, and instead of this float it could be this record value, right? So this, basically this grammar can produce multiple variables in a single line. So this grammar can declare multiple variables in a single line, and through these variables you can also calculate how many spaces you need. For example, by using this line you can determine how many spaces you need for these types of variables. For a you need 4 bytes, and for b you need, suppose each float contains 8 bytes, so for this you need 3 into 8. Okay, so 24 plus 4. So for this whole declaration part you need total 28 bytes of space, right? Right, as this is in a single scope, this declaration is in a single scope, so it will create 28 bytes of space for this variable inside your symbol table. Okay, any questions? Any questions regarding this grammar? Any confusions? আচ্ছা, আমার কথা কি শুনতে পাচ্ছেন আপনারা? Okay, so this is the grammar used for multiple declarations, right? So this part is not needed, but you can read it. So how does the storage work, right? Okay, now we have seen the semantic rules for syntax directed definitions, right? But we have not seen syntax directed translations and their semantic actions. Instead of semantic rules, we are using semantic actions here. Okay, so instead of using semantic rules, what are we using? We are using semantic actions, right? So these are the semantic rules, right? And semantic rules are written at the very end of the grammar. So semantic rules are written at the very end of grammar. So we have a production rule, sorry, at the very end of each production rule. So this production rule has a semantic rule, this, and it is written at the end of production rule. But when we are dealing with semantic actions, we can write semantic actions before the starting of the rule, in the middle of the rule, or at the end of the rule. Okay, So this is basically written as like this. Most of the students get this part confused. Okay, so this is written like this. Whatever we have inside a curly braces is known as what? Semantic actions, right? This is not a semantic rule anymore, it is semantic actions. So the semantic actions can be, can start from the starting of the rule from here, or it can be in the middle of the rule, or it can be at the end of the rule like here. Okay, is this part clear to everyone? If you have any questions, please ask. Yes, yes, production body. Okay. So you have seen, all of you have done lab 3, right? ল্যাব 3 করছি আমরা সবাই। So you have done the class for lab 3, right? Okay. So did the teachers discuss about the dummy non-terminals? What are those? That is the lab specific one, right? But in general, what is a dummy non-terminal? That is basically what you need to do inside the dummy non-terminal. That is not the dummy non-terminal, right? But what is a dummy non-terminal in general? Right. So we can simply replace this. So what we can do, we can simply replace this with a non-terminal. Suppose we can replace this with a non-terminal M, right? So if we replace this with a non-terminal M, then our production rule becomes M produces epsilon. And what is the corresponding syntax or semantic action regarding this? So the semantic actions regarding this is basically this one. So this can be BMC. Okay, it can be written like this as well. Is it clear? So you can see we have converted this into a semantic action, right? We can treat this as a semantic, sorry, we can treat this as semantic rules, right? So we can treat this as semantic rules because it is at the end of every production body. Yes or no? It can be. No, it is not necessary. It is just for your understanding how it actually works, right? So each of these will be a node, right? Each of these will be a node. When you draw the syntax tree, each of these will be a node, right? And each node will have some calculations associated with it. Yes or no? Right. So these are the calculations associated with those nodes. Okay. Okay. So let's keep it as it is. Yes. Basically আপনার semantic action status these are used to these are used in real life applications, right? When you are using it in a compiler and you are setting the rules for each of the nodes, right? So you're setting the rule for the node B. Here you're setting the node rule for a node which is epsilon, right? You're setting the rules for a node, And what are the rules? Those rules are basically your semantic rules. Okay, so you're setting up your semantic rules for each nodes, and these are known as your semantic actions. Clear? Okay, so if we have it like this, when we draw the when we draw the parse tree, right? Let's first draw the annotated parse tree. Okay, let's first draw the annotated parse tree for this. For okay, for into 3. So we'll have t. So we'll have t. This t will produce b and c. Okay, this c will produce another c, which is c1. And this c1 will again produce this. Okay, now so this b, t will produce b and c. This uh, this c will produce this number and c1. This will produce this, and this will produce, basically this will produce 2, this will produce 3, and this will produce, okay, according to this grammar. So accord, according to this grammar, the parse tree is correct. So far the parse tree is correct. হ্যাঁ, যাচ্ছে. So this b produces an integer. So according to this grammar, so far the parse tree is correct. Okay. Now we are trying to annotate the parse tree, meaning we need to write all the attributes. So the t has how many attributes? The t has uh, t has no attribute. Wait, it should have a type and width. Okay? So it should have a type and width. So here it should have t dot type, and it should have t dot width. Okay, so your t dot type will be whatever is the type of c. So c dot type, okay, is equal to c dot type, and t dot width is basically equal to c dot width. So it was missed in the book. Okay, so this is the whole production. This is the whole production. So C has two types of attribute. One is a type and one is a width. So T has a type and T also has a width. So if you look here, B also has a type and B also has a width. So B has a type and B also has a width. Okay. Similarly for C, C for this C produces epsilon. This C also has a type and this C also has a width. So C producing epsilon, this also has a type and this also has a width. But the C producing number C1, this has a width and this has a type. Okay, so it is also missing here. This is supposed to be C dot type. Okay, this was supposed to be C dot type. Okay, so the C dot type is equal to this one. So for this one, the C dot type is equal to array num1 num dot value or C1 dot type, or C dot width is equal to num dot value and C1. So this also has a type and width. This also has a type and width. This also has a type. So I have drawn the annotated parse tree. Is the annotated parse tree correct or am I missing something? Okay, values গুলো দিচ্ছি পরে, but is all the attributes are present is this annotated parse tree, or are we missing some attributes? Look, is every attribute present in this annotated parse tree? Yes or no? Look carefully. We are missing something. কোনটা? এটা দিস লাইন, এই যে এখান থেকে, এই যে। এখানে তো দুইটা অ্যাট্রিবিউট অলরেডি আছে, which is T and W. Do you have this attribute in our annotated parse tree? Why not? We need to include it. Okay, because this can be considered as a node. Suppose this is the node M, so it should also has a node M, right? So this node M can have the attribute T and the attribute W. This is basically epsilon node, right? So we do not need to write uh, any values for them. We can just write T and W, right? So this is basically an epsilon node, but we do not need to write epsilon here. But this node also has two attributes, a T and a W. Did you understand this? কোন পার্টটা একটু বলবেন? Okay, so look here. This is basically a semantic action for a node that produces epsilon. Suppose we can replace this with M. So our rule কি হবে? The M produces epsilon, right? So this is the semantic action for epsilon. Yes or no? Acha. So I can write this as T produces B M C, and this M will produce epsilon, right? And the production rules associated with this epsilon is this one. we can rewrite it in this way, right? So if I rewrite it in this way, so we should also write T produces B, M, and C, right? So M will have two attributes, this T and this W, right? So that is why I'm writing T and W. Okay. No, we need the value because দেখেন এই যে C dot type and C dot width is taking the value from this T and W. Okay. So whenever you have an empty node, you need to write the attributes in here. Otherwise, your calculations will not be correct. Did everyone understand this? কেউ না বুঝলে বলি, যদি না বুঝে এই জিনিসটা তাহলে বলি। হ্যাঁ বলেন। কারণ এটা একটা এমটি নোড না, এখানে তো কোনো ভ্যালু নাই, রাইট? এখানে এখানে তো কোনো নোড নাই, এখানে জাস্ট অ্যাকশনটা আছে। তার মানে কি, এখানে এমন একটা এপসাইলন ভ্যালুর জন্য এই অ্যাকশনটা আছে, বুঝতে পারছি? এই জন্য এমটা হচ্ছে এপসাইলন প্রডিউস করছে। এটা তো কোনো নোড না, এটা তো হচ্ছে জাস্ট একটা সিমেন্টিক অ্যাকশন, রাইট? বাট এই সিমেন্টিক অ্যাকশনটা কার জন্য কখন অ্যাক্টিভেট হবে? যখন এপসাইলন পাবে তখন অ্যাক্টিভেট হবে, রাইট? সো আমরা এখানে একটা নোড ধরে ওই নোডটা এপসাইলন প্রডিউস করে, এটা বলতে পারি। বুঝতে পারছি? আপনার এই যে সিমেন্টিক অ্যাকশনটা আছে এটা কখন অ্যাক্টিভেট হবে? যখন টি তে রিডিউস হবে, তাই তো? সো এটা যদি অ্যাক্টিভেট করতে চাই তাহলে কিভাবে করতে পারবো? যখন এই এপসাইলনটা এমতে রিডিউস হবে তখন এই রুলটা অ্যাক্টিভেট হবে, রাইট? এটা আমরা ধরে নিতে পারি। এই জন্য এই জিনিসগুলো হচ্ছে, এটা এটার কোনো হচ্ছে নোড নাই, এটা দামি নোড হিসেবেই ব্যবহৃত হয়। এখানে জাস্ট খালি রুলটা এক্সিকিউট হবে। ওকে, বুঝতে পারছি? এনি কোশ্চেন্স? আচ্ছা, এখন কারো কোশ্চেন মাথায় আসতে পারে যে হাউ উইল দ্য কম্পাইলার নো when to take epsilon or when to take the actual character string that is given by your syntax analyzer, right? That is given by your lexical analyzer while parsing, right? When we can consider epsilon or when we can consider if there is some actual string like int uh, bracket 2 3, right? So আমার তো এটাও থাকতে পারে। So should I take this integer value or should I take this epsilon, or should I take this opening bracket or should I take the epsilon? How will I know, right? Because if you change your grammar in such a way that it includes a new node which produces epsilon, right? Your parsing table will also be changed. We have seen how parsing table works, right? Parsing table looks for the input and checks what parsing action to take. So it will look for a certain input and it will see it needs to consider the epsilon, right? When it considers the epsilon, it will basically execute this rule and your parsing will remain the same. কথা বুঝতে পারছি? সো যখন আপনার পার্সার দেখবে যে আমার এপসাইলন নিতে হবে না অ্যাকচুয়াল ইনপুট থেকে আমি ইনপুটটা নিব, রাইট? এটা কিভাবে ডিসাইড করবে? ইট উইল লুক থ্রু দ্য পার্সিং টেবিল। যখনই আপনি এখানে একটা অ্যাকশন ইনক্লুড করছেন, whenever you included the action here, your parsing table has already changed। মানে এটা ইনক্লুড করার সাথে সাথে আপনার পার্সিং টেবিলটা চেঞ্জ হয়ে গেছে। তখন আপনার পার্সিং আপডেটেড পার্সিং টেবিল থেকে your compiler will understand how to shift the epsilon or it to shift, sorry, when to reduce this epsilon to m and execute this action or to shift some character, right? So your parser will know। কথাটা বুঝতে পারছি? যাদের কনফিউশন ছিল তারা বুঝছি না আরো কনফিউজড হয়ে গেছে? বুঝতে পারছি সবাই? ওকে, so right, so we need to include this t and w. Okay, সো কিভাবে ভ্যালুগুলো পাস হবে? So how will the values be passed? So if you see b dot type, when b produces integer, so b dot type is integer, so this type will be an integer I. Right? So what is the width of an integer? The width of an integer is basically 4, right? So these values will be passed here. So this type will go to this t, because whenever it is epsilon t produces b epsilon c, the epsilon is basically the t is equal to b dot type and w is equal to b dot width. So we have b dot type and b dot width here. So the type will be integer and the width will be 4. Okay, and from here the values will be passed here. C, when c is equal to epsilon, the we're getting c dot type is from this t, so c dot type we're getting it from this t, and c dot width we're getting it from this w. So the type will be, so the type will be integer and the width will be 4. Okay, now from here we're going to pass. So look at this rule. So from here, what the C of type will be? The C of type will be an array. বুঝি নাই কি হয়েছে? ও আচ্ছা, আচ্ছা সমস্যা নাই, রেকর্ডিং দেখে নিয়ে। Okay, so the type of C will be array. What is the number value here? The number value is 3. So 3 comma C1 type. What is the C1 type? C1 type is integer. Int, integer, right? Okay, so what is the width? So what is the width of this? The width of this is basically calculated here. Num dot value, what is the num dot value? 3. And what is the C1 dot width? C1 dot width is 4. So 3 into 4, 12, right? So the C1 dot width is 12. Again, we need to use this value to calculate this value. এই যে আপনার ইন্টিজারের জন্য কি বি ডট টাইপ কি পাইছে, ইন্টিজার বি ডট উইথ কত পাইছে 4, রাইট? সো এই ভ্যালুগুলো কোথায় শিফট হয়ে গেছে? টি আর ডাব্লিউ তে, তাই না? এইখানে টি আর ডাব্লিউ তে শিফট হয়ে গেছে, তাই তো? এই টি আর ডাব্লিউ থেকে এই যে দেখেন এই রুলটা খেয়াল করেন, এই সি ডট টাইপ আর সি ডট উইথ কই থেকে পাইতেছে? টি আর ডাব্লিউ থেকে পাইতেছে। সো টি আর ডাব্লিউ থেকে এখানে ভ্যালুগুলো আসছে, কথা বুঝতে পারছি? হ্যাঁ হ্যাঁ, এই জন্যই নিছি। ওকে, নাও look here that this will be again calculated like this. So what is the C dot type? The C dot type is equal to array. We'll keep an array. What is the num value? The num value is 2. And what is the type of C1? C1 type is A3 int. Right? Now we need to calculate the width. What is the width? The width is num value. The num value is 2, and we need to multiply it by C1 dot width, which is 12. So total width is 24. Okay, now this will be propagated here. Okay, so the type is basically this one, this whole thing, and the width is basically 24. So for this declaration we need total size of 24 bytes, and we can easily determine this by using this grammar. Okay, so this is the purpose of this grammar. Understood? রাইট, মেমোরি সাইজ বের করা, অ্যান্ড কি টাইপ এটাও ডিটারমাইন করা। ওকে, সো টাইপটা কি, দিস ইজ দ্য কম্পোজিট টাইপ, রাইট? সো এই টাইপ ডিটারমাইন করা প্লাস হচ্ছে মেমোরি কত সাইজ লাগবে এটা ডিটারমাইন করা। ওকে, সো আমরা বুঝলাম তাহলে দিস পার্ট অফ দ্য গ্রামার ইজ বেসিক্যালি this part. This part of the grammar has this rule, right? We can easily use it to calculate the time and the width. Okay, so what if we want to determine the width of this? So suppose we want to determine the width of this thing. Right, so how will you determine the width of this? Okay, so you need to basically use this grammar, right? There is no alternative. You need to use this grammar. Okay, you need to use this grammar to find the width of a record. Will be same as this because it is using d inside the record, right? So we need to find the grammar rule or the semantic actions for this part, right? So it is also given in your book. So, so whatever I did before, here you can find the dependency graph in the book. Okay. Now, for the sequence of declarations, you need to put two things in mind. Okay. So, first, your you need to use this grammar that P produces offset is equal to 0 and D, and D can be converted into TID semicolon, and it has this rule and D1, and this D can be then produced into epsilon. Okay, so we can combine this rule with the previous rule. right? So this can be a given thing, right? This can be a full grammar for calculating all the declared variables sizes for each scope, right? This will be available for each scope. So here we are missing the record one, right? So this t can be this or record, right? So let's implement this. So record also has a, so the record also has a semantic action, right? So we can use it, use this as well. Okay, so this can be your whole grammar for multiple declaration, right? So you can get this in your exam as well. Okay, so using this all the rules, you're going to calculate the offset and also the width. Okay, so let's see. Okay, so we have two classes for this, right? 13 and 14. So I have covered this so far because we do not have time. We're going to look at this in the next class. Okay, so we're going to keep this for the next class, but before that, let's understand few things. What is actually happening in this? Okay, so let's understand this. When we're trying to accommodate multiple variables, we first need to calculate for each scope, right? This is why we are setting the offset to 0, right? So sorry, not for each scope, for each declaration, right? So we are setting the offset to 0, right? This is the offset of your symbol table. This is the offset of your symbol table. Suppose at this point you are entering a new scope, right? And you need to allocate variable information for this variable. So this is your starting point, which is offset, right? So how many uh, memory spaces are you going to accommodate, right? So when we're done this, TID, meaning we are calculating the offset, right? So the type, the attribute will be, the type will be t dot type, and we're going to put that on the symbol table, and the size will be the size of the offset, whatever the offset we have calculated from here. So we have calculated the type here, right? So we have calculated the type uh, variable here, the size here, which is 24, right? So we're going to put the type and the, so we are going to put the type and the offset in the symbol table for this variable, for variable a. Now we are going to move the offset to offset plus t dot width, right? So the offset was 0 and the width was 24. So the new offset will be 24, meaning suppose this is 24, this is 0, this is 24. suppose we have put the variable a here. Now we need to put the variable b, right? So for variable b, the offset will start from 24 and so on. So this is how we are putting the variables in the symbol table based on the offset. Okay, based on this offset. And for record we are basically resetting the offset to 0. Why? Because it is entering a new scope. So for record, suppose record, we have curly braces and we have some variable inside it, right? So we are basically uh, resetting the offset and putting a new symbol table on the top of the stack. Okay, so this is what the code stands for, because we are going to a new scope, right? So try to just overview this, right? Take a screenshot or try to, okay, let me give it on your Discord. Okay, so go through the grammar, because in the next class we're going to see some examples of it, and in that time we're going to discuss in details. Okay, and you're going to also have your assignment on this. So I'm going to post the assignment after taking the next class. Okay, so after I have done taking the next class, I'm going to post that assignment. Yes, কুইজ, আচ্ছা রাইট, কুইজ আপনাদের নেক্সট কুইজ হচ্ছে 19th। আমি আজকে অ্যানাউন্সমেন্ট দিয়ে দিতেছি। আপনি তো স্যাটারডে 14 তারিখের কথা বলছিলেন নাকি? আমি তো এই যে এই জন্য আরো পরে হচ্ছে 19th দিছি। হ্যাঁ হ্যাঁ, যেটা ছিল ওইটাই আপনার হচ্ছে, হ্যাঁ লেকচার 12, অনলি লেকচার 12। আচ্ছা, 19th কি প্রবলেম আপনাদের? আচ্ছা, কুইজের বেশি টাইম